Good evening, everyone. I see a lot of messages in the chat box. So a lot of good evening. So good evening, everyone. A few of them, few doubts. Some of them have asked, will I be given a certificate? Some of them have asked, will there be any money that I have to pay after the end of the sessions? So we'll be answering all your questions. Okay, so there will be a certificate after the end of the 5 sessions after 5 weeks. And will not be charging anything for you to get that certificate. I want to repeat what I've just said. There'll be We are not charging anything. We're not taking any money from you for attending these 5 sessions and to get a certificate. Okay. So we've got many people as per the registrations. 40% of the registrations are from other countries. So we are very glad that you all could join. So a small clarification. I am not the trainer. I'm just giving you an introduction. I'll give an introduction for 5 to 10 minutes about our organization and about the resource person. And after that, the resource person, Mr. Kib Bapuji, he will be delivering the lecture. So is everyone ready? Can we get the recordings of the sessions? We'll see if we can make that arrangement. Okay, so it's been already 3:10, so we'll start this evening. The quantum machine learning will start this session. Okay, thank you very much. Welcome to the QVertex machine learning hands-on session for 5 weeks. So this is the first week where we'll be giving you the introduction to quantum computing. Okay, this is a slide that I've kept. Your microphones are off by default. So thank you so much. So first, I would like to talk about the organization that we are from. This is Qubits. What we do here at Qubits, this is an organization, a technology learning and an innovation organization, where we primarily we solve the problems of the organizations, companies, and we also train students, and we bridge the gap between the students and the industry and the education. So that is the main motto of this organization, and our approach is learn, build, solve, and innovate. Okay, so this is a simple strategy that we have to bridge the gap between learning and the industry. There are many professionals who've trained here, who are working now in very big organizations, and there are many big problems that we solve for the organizations, which I'll talk about in a minute. So our technology ecosystem, we have two main products here, IdeaWise and QVertex. So for the next 5 weeks, you'll be learning about the QVertex. So okay, I'm sorry. The screen is not moving, I see. Okay. So now, I hope everybody can see the screen. So this is the approach that we have at Qubits. The first one is where we solve organized companies' problems. I mean, there are many problem statements that we take up and we solve, and then we train many college students, engineering students especially, and we build them ready for the industry. So our motto is very simple: learn, build, solve, and innovate to bridge the gap between learning and industry. Okay, so we have two main products here, IdeaWise and QVertex. I'll be talking about IdeaWise, and QVertex is something that you'll be going through for the next few weeks. Okay, so IdeaWise is uh, it's a product that we've built where anybody can work on projects. And these days, having an idea is very easy, but to convert that idea into a real product is the most difficult thing. So we've built a product called IdeaWise, where it'll not only give you an idea, but it will give you step-by-step procedure on how to build that idea, what are the technologies involved, how to implement those technologies, where to get the data sets, on so many topics, on a range of topics actually, AI, machine learning, IoT, Gen AI, quantum computing, on all those things. So this is one of our product. And after that, there is something called QVertex, which you will be learning for the next few weeks. Okay, so I won't explain much about QVertex because you'll be going through it. If you have time, I would request all of you to visit our website, hubits.in, HUEBITS, hubits.in. So this is the website. There are exciting products on there. I would wish every one of you after the session is over to go through the website and find what is interesting for you there. Okay, and now we'll come to today's main theme. I mean, today's main class. So why are we talking about quantum right now? So every decade there is a exceptional breakthrough that is happening, especially with the computers. In the 1960s, it is the mainframe computing. In the 1980s, it's the personal computing. 1900s, it's the internet age. And then in the 2000s, mobile computing. And then 2010 onwards, it's cloud computing. Right now, present, we have this artificial intelligence, the Gen AI, and the next AGI, ASI, all these things. And the next frontier is quantum computing. So I'll just give you one example. This is a Willow. This is a chip made by Google back in 2024. Okay, what this chip was able to achieve is they gave a task. It was able to do that task in 5 minutes. What a supercomputer can do in 10 septillion years, which means septillion is 10 followed by 24 zeros. So imagine the chip that you see here, that person that is holding the chip is so tiny, and that can save us 10 septillion years. Imagine the potential of quantum computing. So this is one chip designed by Google, and we are at a very, very, very early stages of quantum computing. If at this early stage, if we are able to save so many years, imagine the future that is there. So quantum computing has the potential to be as significant as AI. The real impact will come in the next 5 to 10 years. So the real impact will come in the next 5 to 10 years. So from classical computing to Gen AI to quantum computing. So I would want you to understand the importance of quantum computing here, because that is where we are heading. Now everyone is talking about AI. And in the next 3 years, they're talking about AGI, artificial general intelligence, that is coming. So at the same time, there is something called as quantum computing that can outrun AI. Well, we wish that quantum computing and AGI, both of them, they shake their hands and work together. So this is where we are heading. So why this workshop? So that's a very important question today evening. So why is just to sensitize, to educate, and to enable you, to make you understand what quantum computing is and why it matters, to educate you about the basic concepts. Even the today's topic that we'll be learning for the next 5 weeks will be dealing it at a very slow pace, and we'll be dealing it like not very, we won't go in depth in that subject, but still we'll be educating you, and we'll be enabling you to empower you, explore and experiment. So this workshop, the main goal is to make you future ready. Okay, see, the next 5 classes will be very important, where you'll have a hands-on experience on this. Okay, so as you've already seen, most of you would have already seen, the first session would be the introduction to quantum computing. And in session 2 would be the quantum machine learning fundamentals. Session 3 would be PennyLane basics. And then from session 4 on, it will be hands-on. And then in the last session, we'll be exploring the QVertex platform. Okay. So these are the 5 sessions that are planned for the next 5 weeks. And I want every one of you to come to these 5 sessions and you'll be ready. So if anyone of you is actually on the phone, listening to this on the phone, you'll be there will be a link that will be pasted on the chat. We would want you to log in, I mean, join the WhatsApp channel so that all the updates will be given. Next week was a long time, so we'll send the meeting link and all the updates, the material. If we have to share something, we'll be sharing it on the WhatsApp channel. So I'd request every one of you, if you're on the mobile, you can just click the link. If you're on the if you're on the computer, I mean on a laptop, take your phone, scan this, you should be able to log in. So I'll just wait 15 to 30 seconds here for someone who would want to take their phone out and log in. The link is kept on the chat if anyone wants to join the WhatsApp channel. Thank you. So about today's resource person, my name is Joseph. I am not the resource person for the day. So the resource person is Mr. Bapuji Kanaparthi. He's the founder and CEO of Qubits. Okay. Uh, so I'll give a little intro about him. Before that, I'll talk what he's doing at Qubits before I give his introduction. So there are a lot of projects that he's working on right now. This is one of the proud moments at Qubits Tech where Mr. Bapuji is actually working with the STPI METI, where we're working on a Li-Fi link. Li-Fi is not like the Wi-Fi that we have here. Li-Fi is the network that is transferred through light. So light and fidelity, Li-Fi. So this is one of the projects that we're working on right now for the government of India. And this is also in the second stage where we worked, and the light fidelity enables high speed, secure interface. I mean, it's like using the internet with the help of light. So that is one thing that we're working on right now. And then when it comes to quantum computing, recently at IISc Bangalore, you see Mr. Bapuji presenting at the National Quantum Mission. And this is one proud moment for us, where this is the only startup from Andhra Pradesh that was selected out of the 65 startups from across the country. The only one from Andhra Pradesh. So this is a very proud moment for us here. And also at Andhra Pradesh, there is this Quantum Valley. This government has taken it seriously, and we are planning to incorporate this technology to the government as well. So, Mr. Bapuji, before Mr. Bapuji comes, I'd like to tell a few things about him. So, Mr. Bapuji is a technology entrepreneur with over 15 years of experience. He holds his MTech from IIT Bombay, and his professional journey spans from a wide range of technologies. He started with IoT and then moved to data science, embedded systems, generative AI, and now quantum computing. And what is so special about him? He's not a person who works on theoretical research, but he takes the theoretical research and builds a real life products out of it, including health, education, agriculture, digital services. And as an educator, he's trained more than 25,000 students. And he is currently the founder and CEO of Qubits, and he's also the director of Alpha Appleton Innovations. And so when we talk about the bridge between education, technology, innovation, and the industry, Mr. Bapuji's journey represents that bridge very well. And today he is going to take us on the first step of an exciting journey into the world of quantum computing. So please join me in giving me a warm welcome to Mr. Bapuji. I'll mute my mic and I'll invite Mr. Bapuji.
Hi Rafi, good evening. Hello everyone, can you hear me? Am I audible to everyone? Am I audible to everyone? Yeah, thank you. Okay, right. Just give me a second, I'll be sharing my screen. Right. So my screen is visible to everyone, right? Thank you. So first I'll introduce about quantum machine learning and then quantum computing. So we will do some hands-on as well, right, all of you. So quick introduction. So most of you know major quantum companies, right? So for example, if you see worldwide, internationally, IBM, D-Wave, Microsoft, AWS, Rigetti, and also you can see Japan companies, these are different Japan companies, and also Google, Intel, Quantinum, and you can see even Chinese companies and also Indian companies. There are companies in Europe. Okay, so most of the companies today are investing in quantum computing, either in the hardware or maybe in the software platforms or SDKs, right? So most of you aware, and if you see, I saw some questions in the chat. Okay, so what might be the opportunities? Okay, so for MSc student or for engineering student. Okay, so I'll be explaining you what might be the potential. If you see here, there are some major quantum computing market leaders. So if you see Quantinum, the valuation of Quantinum is 1.4 to 1.69 lakh crore. That is $16.5 billion to $20.3 billion. So Quantinum is actually creating quantum computers, and also it is creating software. IonQ, actually they are creating trapped ion quantum computers. Even their valuation, if you see 1.4 to 2 lakh crores. Even, you can see Psi Quantum. This is also actually 54 crore to 62,000 crores, $6.5 billion to $7.5 billion. So D-Wave also say. And there are many other companies whose valuation is in crores. So we talk about, electrical vehicle companies or generative AI companies or ChatGPT, OpenAI. So we talk about their valuation. But if you see quantum computers valuation, so most of the players value today is in billion dollars. Even Indian companies, Chinese companies, Europe companies, even if you see South Asia. So there are companies valuation in several millions to billion dollars. So what you can understand from this? So today, business market, okay, so everything, even society is believing that quantum computers can change, transform the world, right? So that is actually belief, and that is why people are investing, right? So you can see a lot of job openings also. You can find in the next coming years. Even today, recruitment is happening. Many are recruiting freshers, experienced people. Okay, when you see the recruitment, basically the recruitment happens in hardware, control systems, electronics, optics, even in software coding, SDK development, machine learning. Okay, so there are different fields where a fresher or a experienced person can enter in. Okay, so understand that. So if you see top Indian players, there are different Indian players also. You might be knowing about QPy AI, right? Apart from that, there are new startups, right? Qubit Force in Quantum, Valley, Amaravati, Andhra Pradesh, India. There you can see QPy also. QNU Labs also demonstrated, quantum communication can happen for a long distances securely. So these are the different companies in, India working on quantum computing, and their valuations also in crores. You can see that. Okay, if you see QPy, currently their valuation is 100 plus crore. That is $12 million plus, and also you can see QNU Labs. They're also having $60 million plus valuation. So even in India and also in other countries, you can see there are different quantum computing companies, right? So you can understand the potential today. So there is a huge potential for quantum computing resources. Quantum computing, for example, you are a good programmer, or you are a good physics student, or maybe you are a experienced person. Still you can get some good job if you can upskill yourself in quantum computing. Okay, so we will see the main thing. So you already know quantum, computing. Maybe you heard about quantum computing, right? So some of you know basics, some of you just started. Okay, so I'll be explaining here. See this, all of you. You might be aware about this pipeline. So this is actually ML pipeline, right? How many of you know this ML pipeline? Please raise your hands. How many of you know this ML pipeline? Right, great. So most of you know the ML pipeline. You know what is machine learning, right? So machine learning applications you see everywhere, right? Today, if you open any OTT platform, Netflix, maybe Amazon Prime, or maybe other, platform, Amazon e-commerce. So all the platforms today are using machine learning. So maybe machine learning or deep learning, or maybe they are using generative AI, or maybe AI agent, or maybe they are using generative adversarial networks like image generators. So there are different models, right? So all these models, the goal is simple. Okay, the goal is to recognize the patterns. Okay, recognize the patterns, classify, classification or regression or clustering. Okay, so we know all these things, right? Even generation, so text generation, image generation, video generation, audio generation, right? So all these are applications, right, all of you? So now this is the fundamental pipeline all of you can see for machine learning. So you collect data and then we process the data, right? We pre-process. So there are different terms like feature engineering, feature importance. So based on that, actually we select the features and then we train the model, right? So there are different models. For training the model, you might need CPU or GPU or TPU, right? So you may be training on any of these model, any of these machines, GPU machine or CPU machine, or maybe in the cloud, right? So, and then once you train the model, then you validate it, whether your model is giving good results or not. If the model is giving good results, then you deploy it. For deployment, you can deploy in computer, you can deploy in cloud, you can deploy in on-premise server, you can deploy on edge device, like, edge device, Alexa, right? Google Mini, voice assistant, right? Most of you know those voice assistant hardware devices, Siri, right? So you might have seen them, Amazon Alexa, Siri. Okay, hardware product is there. Same way, Google has its own voice assistant hardware available, right? So you can directly deploy on edge device also, right? And then it will start predictions. Okay, so if you ask who is the president of USA, then it can answer, right? Because already it was trained on it, right? All of you, already it was trained on this. Right? Is this clear? So basically for whether it is a regression or classification, clustering, or generative model. So this is the flow, this is the pipeline, right? Some of you may be aware about it. If you are not aware, if you are a first year engineering student, just listen to me. Okay. So because you cannot understand if you don't know what is machine learning. This is, for those who already know machine learning. Right. So if you don't know machine learning, just understand this concept. Okay. So this is actually classical machine learning. Classical machine learning uses actually your computer memory or computer resources. They're actually classical means it uses zeros and ones. Computer, if you see computer, basically computer is made of zeros and ones, on and off. Actually there you see transistors, which are switching devices. So they actually play with zeros and ones only, right? So if you open a computer, you can see only motherboard and then rom, okay, and then memory. So basically it is working with zeros and ones. Okay, that is classical computers. So there is a difference in quantum machine learning, quantum machine learning pipeline. So if you see quantum machine learning pipeline and classical machine learning pipeline, so if you see the differences, what are the differences? See the difference, main difference, if you see, uh, the classical ML and quantum ML both are very similar, but the change, where is the change? So the data, right? How you are actually training, That's important, right? So how you are actually training. So that process here you can see step 3. So collect data, sample subset of the data, and then here you are doing quantum feature extraction. Okay, so there are other steps also we will discuss, like quantum, basically what we do is data encoding, and then we create a quantum circuit. So we will discuss in detail, okay, in the upcoming slides. So once you have this quantum feature extraction, so this is where actually you'll be running on hardware, quantum hardware. We don't use, these steps 1, 2, 4, 5, 6 steps in quantum hardware. In quantum machine learning pipeline, you need quantum hardware in step number 3, right? So you need only in step number 3. So quantum feature extraction or quantum, feature modeling, right? There actually you require quantum hardware or quantum simulator, right? Do you understand this? So if you know the machine learning pipeline, so now if you want to become good at quantum machine learning, so you have to concentrate on this step 3. If you can concentrate on this step 3, okay, then you can become a successful quantum machine learning engineer. So what I recommend is, okay, basically, so if you want to, learn step 3, this is a big thing only. It's not that much small, and you don't find any resource, clear resource in the web also. So to learn quantum computing and quantum mechanics, okay. So to learn that, so I'll be helping you these 5 weeks, okay, right? Now, why quantum machine learning? What is quantum machine learning? As I discussed with you, here everything is same. What is the difference? Quantum feature extraction. So quantum machine learning is subset. So if you see here, it is not just one technology like machine learning plus quantum. So you'll be combining quantum mechanics principles, physics principles, quantum computers, and then mathematics and statistics, machine learning algorithms, computer programming, computer science. So everything together, it's actually quantum machine learning. Okay, understand this. You should know quantum mechanics principles. You should know how to create a quantum computer, right? Or at least you should know how to use the quantum computer, right? So quantum machine learning is a combination of different things. What are they? Quantum mechanics, math and stats, quantum computing, machine learning, computer science. So altogether, you can see QML, quantum machine learning. But why quantum machine learning? Already classical machine learning is powerful, right? How many of you agree that classical machine learning is powerful today? How many of you agree that quantum machine learning is classical machine learning is powerful? It is already powerful, classical machine learning, because ChatGPT, you are using ChatGPT, right? You are using Claude. They are powerful. They are fast. They are accurate, right? So then why we have to go for quantum machine learning, right? So I'll be helping you to understand why we need quantum computers for machine learning, why you need to use it. Okay, so I'll be explaining that now. So there are different applications for quantum machine learning, like transport, logistics, finance and insurance, network security. This is one of the major, all are major things. Understand, you can find use cases, live use cases. So insurance, finance, network and security, mainly quantum security, quantum cryptography, QKD, and also you can see other like so you might see QKD, and also you can see post quantum cryptography, also PQC. So there are different concepts you can see in security, and also networking, quantum powered networks and communication is there. So it is being used to communication networks. Okay, so teleportation is one thing which you can use from quantum for networks and also for communication. Even we are combining Li-Fi with the quantum. So Li-Fi plus quantum, actually we are in the process of creating a product for mainly for security of national security and also for defense and military. Actually, we are working on this live plus quantum technology. Right. So that's actually part of security. And also you can see in healthcare, biotechnology, chemistry, energy and resources, manufacturing, aerospace. So you can see different use cases in almost all applications. So it is actually affecting many things like people, environment, economy, right? So it is everywhere. So you cannot say, this is only you should not say this is only for a particular field. Okay, this is not for a particular field. It depends on the type of problem you are solving. Always remember, it's purely based on the problem you are solving. So it is critical to understand what problem you are solving. Then you have to choose quantum machine learning based on the problem. Understand one important thing, quantum is actually in nature. Most of you know quantum computing is in nature, right? Means, so if you understand the behavior of atoms, electrons, you can understand the quantum behavior. So quantum behavior is, actually derived from electronics, physics, atoms. Okay, so chemistry. So you need to, so these are the fields from where actually you are getting quantum computing principles, right? So as already quantum computing principles are there in chemistry, biotechnology, even in healthcare. So directly you can apply quantum computing to the biotechnology, or because the quantum computing works on the same phenomena, their behavior also same. So you can directly use quantum computing with them so that you can produce results which are not possible with classical computers. Understand? So as you understand, as you go on understanding quantum mechanics, you understand they are derived from nature, right? Physics mostly, and then atoms. If you understand atoms also, you can learn quantum computing, right? So basically what you need to understand is, so today we see there are many use cases related to molecular biology, molecular chemistry, and also you see pharmacy, disease diagnosis. Okay, so some complex diseases, it is very difficult to understand what is happening. Okay, so you can use this quantum computing to understand it, right? To predict whether a particular person is going to get a disease or not. So that thing you can easily understand by using quantum computing, because quantum is already there in them. Okay, right. Right. So there are different platforms existing for quantum machine learning, like Qiskit, PennyLane, Circ, and this is actually Chinese one. Okay, so we'll be focusing on Qiskit and then PennyLane of in our classes, and also we have our own platform, that is QVertex. So we will teach that in the last, how you can use QVertex. Is very simple, drag and drop. Anyone can build quantum machine learning algorithms in no time. Basically, just drag and drop kind of builder, auto quantum machine learning. Just upload data set, everything will be done in the platform. So we are going to present how you can use QVertex for quantum machine learning. Right. So now why quantum for machine learning? So hope all of you are following, right? Yeah, just I'll pause here. Everyone is following? Yes. Okay. So I need, see, all of you, it is very important to understand these concepts, because we will be diving into coming to 5 sessions, also like 4 sessions remaining. So it is important to understand basics of all these concepts so that you can learn easily the next concepts also, right? And also actually there are different collaborations, and also we can work together. There are different options we'll be keeping so that we can actually grow in quantum computing innovation and ecosystem. Okay, right. So far no questions, right? So because I'll be asking questions at the end, okay, so that you can learn at the end, all of you. So please follow so that, at the end I'll be asking. So attendance form will be given 15 minutes before the end of this session. Okay. So please wait till, the last so that you can take the attendance sheet. Okay. And also please, carefully understand from now why quantum for machine learning. See, quantum for machine learning, if you see, there is one thing you need to understand. The classical machine learning can understand the most of the relationships. For example, you want to separate cat and not cat, cat or dog. If you want to, classify whether the given image is cat or dog, you can do that. Most of you know this kernel, right? In SVM, support vector machine. If you know support vector machine learning algorithm, so you can actually draw a line boundary which separates cat and dog. So you can do that, right? So if it is in, basically, if the data is complex, if the data is complex, if it is higher order, you cannot easily, represent the data like this. So there actually you find difficult. For complex data, or if the data is having complex relationships, okay, there you cannot use classical machine learning, right? Then you have to move to the quantum machine learning, because quantum machine learning can extract meaningful representations from the data, right? So where there is no possibility to draw a boundary between the two classes. For example, there are two classes C and D. If you want to, classify whether this is C or D, but if the dimensions of this data is more and the relationships are, basically complex relationships, you cannot separate in classical ML. So how you can separate? So you need to go for higher dimension. So higher dimensional space. Okay. So in quantum machine learning, you can go to the higher dimensional space where you can separate these classes so that you can easily predict, right? You understood, right? Okay. So it is all about how you can recognize pattern from the complex data. Complex data means complex data where there are complex relationships. Okay, all of you. Right. So the main bet is this: quantum systems can represent certain relationships in data more naturally than classical math can do. Understand that. That's the advantage. Okay, because quantum systems can encode complex relationships more naturally. Okay, because they are designed for the same. Right. So another important thing is exponentially large feature spaces for free. Okay, so you can create large feature spaces. So not one dimension, but you can create more dimensions. Okay, not just one dimension, two dimension, three dimension. You can go further. If you see the relation here in classical, to explicitly work with 2 power 50 dimensional feature space classically, you need more memory, which is not possible at all. Okay, not possible if you want to work with 2 power 50, 2 to the power 50 dimensional feature space. But in quantum, it is possible with 50 qubits. With 50 qubits, you can do it, because 50 qubits here, n qubits, produces 2 power n dimensional space, right? Means 50 qubits can produce 2 to the power 50 dimensional space. That is possible with just 50 qubits, which is not possible with the classical computer. Right? Understand this. Which is not possible with the classical computer is possible with the quantum computer because of its, superposition and entanglement principles. So we'll be discussing about what is superposition, what is entanglement. Okay, superposition and entanglement. Because of them, you can actually, n qubits can be represented in 2 power n dimensional space, right? So it is equivalent to 1.12 quadrillion dimensions, which is huge, right? So that is the power of quantum computer. So when you talk about a quantum computer, why we talk about 50 qubit computer? 20 qubit computer, 10 qubit computer. So you say number, right? So because this number matters, right? So the power of the quantum computer depends on this number n, right, all of you? Right. So now you can see here how quantum kernel trick. So you know kernel trick, right? So same thing you can do with the quantum. In quantum, what do we do is, so we use here feature map. This actually converts classical data into quantum state, and we send this to the quantum circuit where actually you can find huge quantum feature space, because if you give 50 qubits, then you will be getting dimension 2 to the power 50. So that is the advantage. Then you can easily find similarity and you can separate two classes. You can draw the boundary kernel between these two. That is possible. That is possible of you, right? This is because of this particular superposition and entanglement. Superposition and entanglement. Right. So finally, you can understand this. The kernel or similarity function now lives in a space no classical computer can build or store directly, right? That is not possible with the classical computer, is possible with the quantum computer. That is the advantage, right? So another important thing is basically you need to understand classical ML generally works with only low dimensions. Okay, that is actually low order relationships. Whereas if you have a multiple relationships, each feature depends on other, it's very difficult to predict. In such case, you can go with the quantum machine learning, right? For example, molecules. Molecular properties depends on the interactions among atoms, right? And image textures also. Financial, time series also depends on different factors, right? Because the war can change this. War can change this. One country, floods in one country can change the scenario. Floods in one country, right? So understand this important thing. Financial time series. It's not just the history, data history, but it's about the different factors, right? The factors such as war, uh, disasters, calamities, and also the condition of the country. So there are many things influence financial predictions, right? So you cannot just go with the some LSTM. Generally, what we do is we use LSTM, ARIMA, right? But how perfect they can predict? If suddenly war starts, these two models will fail. Yes, so how many of you agree? Suppose you are predicting based on ARIMA or LSTM, financial predictions. If you are doing it, stock prices you are predicting. If suddenly war comes or suddenly something happens, what happens? Right? So generally, so basically you have to consider different factors over the time. There are different dynamics, system dynamics, right? So there are different dynamics in our system, whether it is a financial system, whatever it may be, there are dynamics. So you cannot capture dynamics in a machine learning model, right? But you can do that in quantum machine learning, right, all of you? So hope this is clear, right? If you're able to understand, please raise your hand. If this is clear to everyone, please raise your hand. Yes, if you're following, please raise your hand. Right, thank you. Thank you so much, all of you. Hope you are following. Okay. So if you need anything, you can type in the chat if you're not able to understand any doubts also. Okay. So I'm going to answer all the queries and questions. Okay. And also you have a WhatsApp group where you can get the answers to your questions as well. Okay. Right. Now, example. So you know how to predict house price, right? So if you know the house size, you can predict the price. But the problem is if a house size increases, price increases. Normally we know that, right? This simple regression model, simple linear regression model, right? Most of you work with the linear regression model. How many of you know linear regression model? Right, very good. Thank you. Thank you so much. Thank you. Right, but if you have size, location, age, bedrooms, amenities, price. So basically see, if you have more features, suppose a bad smell is coming near to the big house, then if the home is situated near to a river where there is a much erosion, what next? Right. So, this is not just about the size of the house and price relationship, but there are other factors also, right? So we have to consider those factors also. Quantum can capture all these relationships. That is possible. And also, if you see higher order drug discovery, like basically for drug discovery, you need to understand a lot of things, atoms, how they are, combined together, what is the bond, angles between them, distances, electronic properties. Based on that complex thing, you can predict a drug. So this drug is good for this disease. So because, everything works at the molecular level, right? So for that, actually, you need to know how they work, right? So molecules toxicity or drug effectiveness depends on that. So you need to go for quantum machine learning in this case. And also we have financial risk already discussed with you, right? Another use case, if you see fast charging battery material design. Today, there is a lot of research after EV. We know EV, right? Yeah, EVs, electric vehicles, autonomous vehicles. We see drones, we see robots. All these require rechargeable batteries, right? So rechargeable battery. So how quick you can recharge a battery? That is important, right? So today, quantum machine learning can help to find the materials, so the combination of materials, which can actually produce a better fast charging battery, right? So to find that particular one, there are different relationships like ion, how ions are moving, what is the conductivity of the electrons, what is the temperature, charging rates, electrode structure, crystal structure, material composition. So how they work together, based on those parameters, you can predict fast charging, long cycle life, high safety. These are the main goals, right? To achieve that, you can try using quantum machine learning. So today there are companies who are trying for this. Right. So it is clear to everyone, right? Classical ML finds patterns using everyday math, but quantum ML best does some data like molecules or data with deeply tangled relationships, means with entanglement, superposition, you can do more better with the higher order data, right? So this is what we have seen, right? So all of you clear, right? So why we have to use quantum machine learning? So do you understand why we have to use quantum machine learning? Yeah, thank you so much. Thank you. Now we will come to the important aspect. Okay, so we have a limited time, so I'll start with that as well. So now in quantum ML pipeline, we discussed that feature encoding and also quantum processing. These are the important aspects, right? And here this can be done 1, 2, 3, 5, 6, 7 steps can be done in computer, classical computer, but this fourth step, this should be done in the quantum computer, right? So we'll do that. We discuss this. Now there are different use cases. In your free time, I request you to please go through them because they will help you a lot. Okay, so these are the case studies. You can see how HSBC is trying to use this for predictions. So you can see here. So they are using, HSBC is trying to create algorithmic trading with IBM. Okay, so quantum enabled algorithm trading. So they are using for trading. Okay, and also you can use other use cases like fraud detection using quantum machine learning. So you can see here, these are fraud detection using quantum machine learning. So this is another company who are using this for on MasterCards. And also you can see other use cases. Hyundai is also using, and also IonQ manufacturing, they are working. And also we can see other parts like IBM also has different use cases. So I'll be sharing all the links with you, and you can just explore after the class and try to understand what are the different use cases today for quantum. machine learning, what you can do, what you can build. Okay, right, all of you. Just I'll be sharing these resources with you. Right. Right. So we'll move to the next. Right. So this part we'll be learning now. So to understand how you can actually train quantum machine learning models. So basically you need to know how to create quantum circuits. So to create quantum circuits, you should know what is qubit. You should know what is qubit, how to transform or change the qubit states, how we can do that. That is actually using gates. You can use gates, quantum gates. There are different quantum gates for superposition. You can use one gate, entanglement, you can use a gate. So how you can use gates for teleportation. So there are gates for different, techniques or circuits. Okay. So we are going to create circuits. For creating circuits, first you should know what is a qubit, what are the gates, what is superposition, what is entanglement, what is, interference, what is measurement. Okay, so these concepts are essential to understand, and also you should know what is measurement as well. Okay, so these are essential before creating a quantum circuit. So we are going to create quantum circuits in our class. So in these sessions, okay, so I will show you one or two examples here. So we already know, we discussed, no need to go into this. Okay, so you'll be focusing now on superposition, entanglement, quantum mechanics, and qubits, how you can use them for quantum computing. Right. So what is a quantum circuit? So we just saw this in this, actually this is a quantum circuit. So if you see machine learning, whether it is a machine learning or it is a optimization problem, or it is a some security based problem. So for example, Grover's algorithm, whatever it may be, basically it is actually quantum circuit. Okay, it is a quantum circuit. So we need to know how to create quantum circuits. That is a very important step in quantum machine learning. So I'll be teaching you now how you can create a simple circuit. Okay, and then I'll teach you some important principles as well. So a quantum circuit is a program that runs on the quantum hardware, right? So you have to create a circuit, and this circuit will run in the quantum hardware, right? So always remember, quantum circuit, you can visualize it as a like a network, neural network. Okay, so in classical computers, neural network, right? You can visualize a quantum circuit like that. Okay, so where basically you have to train the quantum circuit, mainly theta parameters, theta 1, theta 2, these are the parameters. So we'll discuss more details about them, how you can train and update these theta 1, theta 2 and other parameters, right? So these are actually the quantum circuit consists of, layers with these theta 1, theta 2, theta 3. So ultimately we have to train the circuit, means we have to update theta 1, theta 2, so on. These are the trained parameters. Okay, so actually in this circuit, these are the trainable parameters. Understand this. So what is a quantum circuit? It is a sequence of quantum gates you are applying on qubit, right? It's very simple. Apply gates on the qubits. That's what you do, right? So how to apply? So I'll be showing you. Right. So there are three stages of your data encoding: variational layers, and then measurement. So basically data encoding is converting numerical data into quantum state. Second one is we have to train. So you will be using different gates, like mainly rotation gates, RY, RX, okay, RJ, these gates to process the state. And finally, you'll be measuring it. This is what we do in the training process, in the quantum machine learning training process, right? So this is actually a simple diagram to understand this. Right, all of you. This is actually quantum circuit. So here theta 1, theta 2, theta 3, you can see here. Okay, and Ry, these are the rotation gates. So you can use them, theta 1, theta 2, theta 3, theta 4, theta 5, theta 6, theta 7. The ultimate goal is to, update the theta 1, theta 2, theta 3 so that you'll be getting correct predictions. Okay, correct predictions. So to minimize the loss, you are adjusting theta 1, theta 2, theta 3, theta 4, theta 5, theta 6. Okay, so this adjustment, basically this is a quantum circuit and entirely is a classical only. Optimizer is also classical, loss function, everything is classical, but only you see quantum circuit, right? Right, all of you. Right. So before moving, so I'll be showing you some basic examples of how you can use quantum machine learning. Simple superposition first we'll understand, and then we see. So I'll be showing you some examples to understand this. Just give me 1 second. So I'll be showing you some examples to give you more understanding about what is qubit and how to use qubits. So we'll see what is a qubit. Most of you know this. If you're a beginner, just understand what is qubit. Okay, so basically we know that classical computers stores data in zeros and ones, right? So most of the time you see a classical bit is 0 or 1, either on or off. Okay, so if you see in transistor level, means in chip level, basically it is voltages. On is actually some voltage, high voltage, and off is actually low voltage, right? Whereas if you see qubit is actually not 0 or not 1. It is not 0, not 1. So it is in between 0 and 1. Understand this. Okay. So a qubit is generally between, either it is not 0 or 1. It is either 0 or 1 in between. Right. So you can see here in the block sphere, you can find the moment of this qubit. This is actually qubit. You can see, right? So when it is in superposition, it is not 0 or 1. Okay. So that is a qubit. Bit is already right? So basically 0 or 1, that is actually a bit, right, all of you. And if you see, when you see the qubit, basically you can rotate the qubit can be rotated. So basically where is the qubit? You can locate here. This is actually qubit, all of you. And this is actually block sphere where you'll be showing the location of your qubit. Okay, so if you rotate by using unitary gate, you can see here how you can rotate this. And basically when you measure, you will see either 1 or 0. Basically measure, what it will do is it brings from superposition to means qubit to the bit. It will be changing from qubit to the bit, means it will be losing the superposition. Okay, so when you measure, your qubit loses its superposition state, right? And you'll be either getting 0 or 1. You can see here it is 1 now, and if I rotate again, and if I try measure again 1, so you can see it will be either collapsed to 0 or it can be collapsed to 1 when you're doing for measurement. So measurement is key. So if you see here in this diagram, so basically this is where you see the measurements. This is a measurement. See measurement. So in the circuit, actually your qubit is there, and it is actually you are actually changing the state of it. But when you measure it, final outcome is only classical because you'll be getting either 0 or 1. So that is actually what you can understand. And don't think that here qubit state is hidden. It is not hidden. We cannot see it, right? Because it is it is not hidden. Understand this. It is there, but we cannot see that. Okay, so when you measure, then you can see either 0 or 1. You can see either 0 or 1. Okay, so that is actually measurement. So measurement is important for predictions and also for adjusting the theta, because if you are getting wrong predictions, then you have to adjust theta. Okay, using back propagation, you adjust theta so that you will get the correct predictions. If you get the correct predictions, then you can stop the training process, and then you can use these trained parameters theta 1, theta 2 already trained. You can deploy in classical computer also, right? So there is a way. So there is a company called as Kipu. So they are actually recently they published a paper on this, how you can deploy quantum, trained models in classical computers efficiently, right? You can do that. So deployment, no need of quantum computer. You cannot use it. It is too costly. Okay, you cannot run continuously in the quantum computer. See, there is no quantum laptop. Okay, so understand this. So there is no machine-like computers today. They are mobile, wherever you can take and you can use classical machines. But quantum machines are not like that. Okay, so even it is costly. So you cannot just deploy in quantum computer, right? You can use that for training. Understand this process. Okay, right. Right, all of you. So this is clear to everyone. Everyone understood, right? What is qubit? Do you understand what is qubit? But there is a problem with the qubit stability. So today, many of you know that for qubits to make them stable, and also there is a problem called as decoherence. Okay, losing quantum state. So sometimes it will stay lose the state. That is the main problem. Okay, so it should not lose the state, but actually quantum computers cannot store the state for longer time, right? So you cannot keep there is no memory till okay, but people are doing research for QRAM. So they are some people are working on QRAM. So how you can bring the QRAM. Okay, so that is another research point only, right? So currently if you see basically what happens if there is a noise. Okay, if there is a noise, you can see quantum qubit will become unstable, and you can see here actually it will lose its state. Then there is no point. Okay, so it should not lose its point. That is actually it's actually decoherence. So today in the NISQ era, so these are the two important things we need to deal with. So scientists, how they are working, they are creating systems to cool the quantum computers so that they can keep quantum qubit stable. So for that they are using different so cooling systems in quantum computers. If you see, there are many, right? So cooling systems in quantum computers, you can do research at the home. Okay, so you have to go down into a lot of negative temperatures. You have to do that, so you can study what computer requires what, and they are using actually cryogenic free. Some are using cryogenic. Okay, you can see here 50 millikelvins. So just do just go through what are the different types of equipment they are using for cooling quantum computers. So most of the quantum computers, you cannot identify quantum computer in this. Actually there is a control system. This is entirely control system and cooling systems only. Most of the time, what occupies a quantum computer? Control. One is control, another one is cooling. Actually these are heavy big. Actually if you see quantum chips, suppose Google Willow already Joseph already shown okay what how Google Willow quantum computer chip looks, right? Semiconductor based chip, that one. Okay, so actual chip is small, but actually control and cooling, it becomes a big large system, right? So stability is one of the important aspect. Okay, you need to understand. And also measurements, you cannot copy qubit. This is actually one of the important things. So this is called as no cloning theorem. So there is no possibility to copy a qubit. You cannot do that. Okay, that's actually another important thing you need to understand. Okay, so this is another important property, and also other properties are there. This is actually superposition where actually the 0 and 1 at a time. So there is no state. So if you measure, then only you can see the state, right? Either it can be 0 or 1, but when you collapse, then only you'll be getting 0. So today just I'm showing basics. If you are very familiar with these, no problem. Okay, so I am teaching for those who are just coming to understand introduction to quantum computing. So I request you please bear and also be with me so that you can go through this, right? So another one is entanglement. This is another important. So basically entanglement is useful. Why we use entanglement? Do you know? See, superposition is powerful. Why? Do you know why? Because of number of states you can create. Number of states you can create. Number of possibilities that you get. See, one, if you're using one qubit, So you can have 0, 1, and then there are different possibilities are there. And if you have 2 power 1 possibilities, and then 2 power 2 qubits, 2 power 2, if there are 50, then you will have 2 power 50 possibilities. So this is possible with the superposition. And also you can see the next property is actually entanglement. Okay, so quantum entanglement. So quantum entanglement is very helpful for correlation. How qubits are related. Okay, if you want to find the relationship between data, because qubit represents your data, right? So basically you are converting your data into qubits, and basically qubit states, right? So basically this correlation actually will help you to understand the relationships between the data. So entanglement is a very important property to understand the relationships between qubits. All of you means data. So if you see here, if you entangle, what happens, they will be changing the same. So this will be representing the state. When I collapse, measure, so you can see the same position. So 0, 0. If both are the 1, 1, if they are both the same position, so when they are in superposition, randomly they will be doing this. Qubit is random, and this qubit also will be in the random nature. But when you collapse, both will be related. So there must be some relationship between them, right? So this is the powerful feature. Okay, this special relationship is one of the most powerful features of quantum computing, and this helps solve complex problems more efficiently. That is the advantage of this particular, quantum entanglement. So we have, actually this purely quantum entanglement, and also you can see how different qubits actually designed, like tapped ion, superconducting, photon, silicon spin, and how actually they work. So you can see here. So I'm not showing everything here. So these actually trapped ion based computers. Most of trapped ion computers were designed by, I think, IonQ, right? IonQ is designing quantum computers using trapped ion. Okay, so this is actually trapped ion quantum computing company, right? You can just go through that. And also there are superconducting based companies also there. Most of them are like those who are in semiconductor companies also working on the superconducting, right? So this is about qubit, and I'm not going to show everything because we don't have time. Suppose if you want to create a superposition, I'll be showing using our own playground, where you can create your own superposition. For superposition, you need Hadamard gate, H gate. Okay, so in gates you can find what are the different gates. Actually, there are different gates like Hadamard gate, and also you can find poly X gate, poly Y. Basically there are different gates we can find. So just give me 1 second. I'll be showing you how you can actually create a simple superposition. So I'll be creating a qubit. So this actually it creates a qubit state, 1 qubit, and then I'll be applying H gate. This is actually required for superposition, right? And then basically you need to measure collapse. So for measurement, I'll be measuring with 1024 shots. Okay, so this is actually simple. How you can apply Hadamard gate on qubit for superposition. Okay, and I'll be running this. So when you run this, you can see the simulation results, total measurements, quantum states, phase angle. So you can see here, so zeros 508 times measured, and then ones 516 times measured, right? This is the actual circuit for this particular, applying superposition, right? And also you can see the state of the qubit in between. This is a state vector. And also if you want to find how the quantum state is, so you can see quantum state, how it is changing, right? So you can see that. So just, you can see how this is actually created, right? This is actually how you can see this. These are not 1, not 0, but you can see it is between 0 and 1, right? You can see that in the block sphere, right? All of you. So is this clear? This is how you can create the superposition, right? So even a qubit in superposition, and also you can use, instead of, this, you can use Qiskit also. for creating superposition and entanglement. So I'll be showing you how you can use. I think we don't have enough time to show this. I'll show this in the coming session. Okay, so I'll explain in the coming session. Okay, because we have already we crossed 4:15. So please kindly be with me. Right, this is actually how you can do how you can introduce superposition. And also there are multi-qubits. When you want to work with multi-qubits, means not just one qubit but multiple qubits. So multi-qubits where actually you'll be combining, because you don't just use one qubit. There is no point to use the one qubit. So multi-qubits are powerful because they can only understand and learn from the data, right? That is essential. So for this, actually you have to use multi-qubits. On multi-qubits, you have to use multi-operation. Entanglement is a multi-operation. It is not about one qubit. I already told you. Okay, it is between qubits, so that it can relate with other qubits, right? So entanglement you can create between multiple qubits, right? For multiple qubits, you need multi operations. Okay, so that is actually multi operations. So where you can use multi operations. For example, I'll be showing you one example for multi operation gate. So if you see the C0 gate, C0 gate is essential for entanglement. Okay, so we use C0 gate. What is C0 gate? For example, there are two things in C0 gate. One is control qubit. Another one is target qubit, right? This is actually control qubit. And this is actually target qubit, right? So if I turn on this switch, now you can see this is changed, right? So basically see, if you control this, then only you can apply something on this qubit, target qubit. Otherwise, you cannot apply anything on this qubit. So CNOT gate, basically control NOT gate is a quantum gate that generally uses 2 bits. Understand is basically this is essential to create quantum entanglement. So generally we use this for quantum entanglement. Okay, all of you. And also we have other gate like, so for creating this, you can go directly how you can create a quantum entanglement. Okay, so I'll show you, right? First, you have to create a qubit state as I discussed with you. So directly you can do that in the playground. Okay, so just I'll be creating here. 1 second. So states, I'll be creating qubit state. So I will be creating 2 qubits. Okay, not just 1 qubit, 0, 1, 0, 1, 2 qubits, and then so apply superposition, because basically it is important. You cannot create entanglement unless there is a superposition. Okay, so you need to apply superposition, and then you need a CNOT gate. CNOT gate. So you'll be applying on qubit, and then CNOT gate you'll be taking target control gate 1, and then another is a target qubit. So this is actually simple. You are applying superposition, and then we are using C0. So this is a control bit, and this is actually a target bit, right? All of you. And then you'll be applying measurement. You'll be applying the measurement. When you run this, basically it is creating entanglement. Creates the entanglement, right? So you can see the circuit for entanglement, right? You can see 0, 1, 1, 0, because we kept this 0, 1, 1, 0. So it will be changing. So whatever the state it is, basically the outcome will be related. Both will be related, all of you, right? So this entanglement, right, all of you. So we'll go through them more detailed in the upcoming sessions. Okay. So we saw so far. So there are many things we can do. I'll explain, because we have different platforms. Not only this one, actually quantum machine learning, where just you can log in and build quantum machine learning projects. So I'll show you. So this we will give you detailed explanation in upcoming sessions. Okay, so directly you can create experiment, first experiment with quantum machine learning. Just choose any data set, or you can upload data set. So diabetes is selected, and directly you can see about data set and everything, right? And you can just auto apply, it will start running. Okay, so you can directly see everything through the auto application. Okay, so directly it can choose everything and it can run. So you can see everything and you can start running so that the model will start running and you can see the code generated for PennyLane and also others also. So you can see it is running, right? So auto apply means just upload dataset and it will start running for you. Automatically it will select everything and it can run for you, and you can edit this code and you can build machine learning projects for you, quantum machine projects. This is another thing I'll be teaching you this tool so that you can learn. So you can see epochs, each epoch, how much accuracy you are getting, what is the training loss. So you can see everything in real time. You can see everything in real time, so that those who are beginners, those who are doing research, those who are developers, you can use this platform and you can do wonders, okay, in quantum machine learning, right, all of you, right? So hopefully you got the attendance sheet, right? The form. How many of you got the attendance form or attendance sheet? Got it, right? Okay. So I request you, it is important, attendance is important for this program. Okay. So without attendance, it is not possible to give us, a certificate. So we cannot give without attendance. So request you to please be with us and please fill the forms. Okay, all of you. And, in the upcoming session, we will continue from here where we left. Okay. So we are still learning quantum computing. And then I'll introduce to the notebook just I have shown how you can use Qiskit, how you can use our platforms, okay, how you can actually do well with this. Okay, so now we are open to questions. You can, we can answer a few questions, not all. So hope all of you are able to understand, right? So do you love this program? First, session. So yeah, can you please post attendance sheet here once again? I request team to post attendance form once again. So team, everyone, it will be posted. So please find the Google form. I request you. Can you see the Google form in the chat? I request everyone, please do it. Okay, so basically, see all of you for beginners and those who are learning. Actually, we created a wonderful platform just now I have shown, right? So there actually from basics to the advanced things, everything you can drag and drop kind of thing where you can learn and explore quantum computing and quantum machine learning. Okay, so you can explore more and you can see that. Right, if you have any specific questions, please let us know. So session recording will be shared through email. Please find session recordings. Okay, our team will share session recordings. Okay, you can go through for view, it will be available. Okay, and you can find all our communication through WhatsApp group. So please join our WhatsApp channel so that you will get almost all information, right? Please ensure to join our WhatsApp group, all of you. Don't miss it, because so we don't just stop with these 5 sessions. You'll be having many things. Okay, so we'll be doing many things. Please do it, all of you, right? So if you have any questions, can you please explain which similarities for quantum? So you can use Qiskit based, or you can use IonQ, okay, simulator. So thank you so much, all of you. You can share your feedback in the chat. I request you to please share your feedback in the chat. Please do it, all of you. Everyone, please share your feedback in the chat. Please do it, all of you. Request everyone, please share your feedback, okay, so that we can do more better in the next session. So recording will be provided and slides we may not provide. Okay. Certificate will be provided after 5 sessions. Please attend all 5 sessions and get the certificate, all of you. Okay. So thank you so much for joining and making this program so great and successful. Thank you, all of you. as if right, those who are having doubts, you can type. See, first years, yes, you can learn. There is no limit, age limit, all of you. Remember this. So if you want data set on finance practical, you can actually collaborate with us. If you are a financial background guy and you can do research, okay, we can help you, Venkatesh. So your feedback is so useful for us. Please leave the feedback so that next session would be more better. Okay, we try doing that. So Pawan, yes, you have any doubt, you can type there, please. So next session, everything will be posted, all of you. Next Saturday will be the next session. Next Saturday, please be ready. Next Saturday, we'll be sharing all details with you. So you can actually, any admin, group admin, our group admin, you can contact, right? So very good, Pawan. That is enough. Okay, you can start working with. Okay, so you have enough knowledge. Okay, you can start working with machine learning also, but you need to know basic machine learning. That is essential for doing this. Okay. So Manal, background in physics and research focused quantum computing. I found this session very helpful. Thank you. Thank you so much, Manal. So Lavanya, yes, we do have. Okay, so you can share your resume with us. So the session is recorded, yes, Devi. You will get it. Okay. Yes. At the end of the session, so we'll be checking how well you are doing. So there will be assessment where we'll be checking, and I know those who do very well in the assessments can be invited as a part of our collaboration team. You can be part of our team. You can work with us. So as a part-time, or you can just as a research partners. So industry case studies link, okay, it will be shared in the group, WhatsApp group. Okay, and also I'll share now also. Just give me 1 second. So please find industry use cases. So just I shared with you. Please go through those industry use cases. Yes, Mukesh, it is very useful. Okay, but what I suggest you is parallel learn machine learning and quantum computing. Don't just go with the quantum computing. Okay, so if you are working with quantum computing, you should be good at one technology, like either optimization, or you should be good at machine learning, deep learning, or you should be good at security. Okay, so one aspect should be there, Mukesh. Sure, Pawan will share with you. So please ping us in WhatsApp. Okay. Yes, definitely it will be useful, Nikita. Thank you, Mukesh. So we cannot provide you for free access, okay, because we have to pay the cloud cost, but we can provide you at a affordable price, very low price that can be done for the those who are attending this session. If you are really interested, please let us know. We can give you at a very affordable price. So just to compensate our cloud cost. Okay. Yeah, thank you. Very good. Ishan. Yeah, thank you for your advice. Thank you so much. So we will keep posted. Okay, Kottapalli. Right. So please be in touch, all of you. So we'll be closing the session. I request everyone please be in touch in WhatsApp so that we can connect and we can discuss all your doubts. Okay. Yeah. Yes, Mohammed, Khan. So we'll share information with you. Okay. So you please ping us in our WhatsApp. Syed, actually, your background is good, physics background, because physics background is so good. Okay, and your area is quantum cryptography. Yes, you can start learning QML. What I suggest is focus on quantum first, and then you can start working with cryptography, and also parallelly you can work on machine learning, because what you lack is actually machine learning basics. Okay, so just start learning machine learning, then you can do it. Yes, Khalil, there will be, yeah. So there are different projects are there. So in WhatsApp group, we will share some sample projects. Then you can see. Thank you, Sayed. Yes, we will share the resources. Yes, sure. Thank you so much, Ishan. So to start, basically I'll give you roadmap next week. Okay. So please be there. How to start? So I'll give you a roadmap. Okay. So I will share with you roadmap, Ankita. Yes, Nikita, it is possible. Okay. So if you want, yes, we can help you. Thank you. With this, we'll be closing the session. You can connect with us on WhatsApp. Maybe some of you did not get answers. Okay, so I did not see all the questions yet. So I'll keep posted. Okay, yes, so everything you can post. So we'll connect with you, all of you. Thank you so much. Thank you. With this, we'll be ending the session. So you'll get the recording. Thank you, Svera. Yeah. Yes, already it is there in the group. Okay, you can just join the group. There you can. So there is a channel and group. So you can actually see our team. So you can directly send a message to our team. Okay, right. So Ankita is saying in WhatsApp group we cannot send messages. Okay, so you can go to the channel. You can connect with us, and also our team will be there. You can see the group admin. You can just ping to them. They will give you everything. Okay, even my number also there. Okay, you can ping me as well. Yes, Venkatesh, it is in Vizag. Vizag, Andhra Pradesh. Yes. Yeah, it's nice to hear, Venkatesh garu. So yeah, so we'll check out how you can connect with us because we are near to you, right? So thank you, Sujit. Okay. So we'll share in the WhatsApp group itself, Ankita. Okay, Ishan. So we'll share details with you there itself. Okay, right. Thank you. With this, I'll be closing all of you.